This PowerPoint video presentation is going to be over calculating the volume of water in a cylindrical tank. As a preface, I do not own any of the questions or material presented in this video, as it was all sourced off the open internet. I have, to the best of my knowledge, presented the proper formulas and correct answers, as this is a study guide and for educational purposes. If this helps you learn, that's great. Here we have the formulas for calculating volume off the State of Florida formula sheet. As always, I recommend getting a copy of whatever sheet your testing agency provides and use it while practicing the math so that you can get familiar with it. There should be a link to a previous video where I do a brief overview on formula sheets. So when calculating volume for a cylinder, we have two different formulas. We have 3.14 times the radius squared times height. So that's when they give you the radius. And our second formula is 0.785 times the diameter squared times height. So that's when they give you the diameter. Also note, volume solves for cubic feet. So the unit of measurement must be in feet. So for a general refresher, in a circle, the radius is the distance from the center to any point on the circle's edge, while the diameter is the distance across the circle passing through the center, which is essentially twice the length of the radius, meaning the diameter is always double the radius of a circle. The height, I would hope, is pretty self-explanatory. Also, to note, height can be interchanged with length or depth. So let's practice our first question. How many gallons of water can a tank with a radius of 30 feet and a depth of 20 feet hold? I always like to pull the known and the unknown out of word problems so it's easy to keep track of the variables. What we know is the radius is 30 feet, the diameter is 20 feet, and we're looking for the gallons of water, so the volume. So here we have the volume formula when given the radius, 3.14 times the radius squared times the height. And remember, on our formula sheet, we are solving for cubic feet, so the units of measurement must be feet. They already are, so we can go ahead and plug these into our formula. So we have 3.14 times 30 foot squared, so 30 times itself, times 20 feet. When you do the multiplication, you get the answer of 56,520 cubic feet because you have feet times feet times feet. So we're going to have to convert this to gallons. There are 7.48 gallons per cubic foot. So to convert, we need the unit that's going to go away to be on the bottom, so it cancels out. It's dead to us. It's buried, so it goes underneath. So you have 7.48 gallons over a cubic foot, and that will cancel. So 56,520 cubic feet times 7.48 gallons over a cubic foot. Cubic foot will cancel out. Cubic feet, I'm going to go between the two. Sorry if that bothers you. You do the math, and you're left with a volume of 422,769.6 gallons. What is the volume in gallons of a tank that is 22 feet in diameter and filled to 8 feet deep? So we're going to pull out our known and our unknown. So what we know is we have a diameter of 22 feet and a depth of 8 feet. We're looking for the volume in gallons. So the formula is 0.785 times the diameter squared times the height. So 0.785 this time because we're given the diameter. And remember, depth is interchangeable with the height. The units of measurement were already in feet, so we can go ahead and plug it into our formula. 0.785 times 22 feet squared, that's the diameter, times 8 feet. We're going to do the math, and you get an answer of 3,039.52 cubic feet. Again, it's looking for gallons, so we're going to have to convert cubic feet to gallons. So there are 7.48 gallons in a cubic foot times 3,039.52 cubic feet. It's going to cancel out, leave you with gallons. Let's do the math. And you end up with 22,735.609 gallons. A circular tank has a radius of 16 feet and is 23.5 feet high at the spill point. What is the capacity of the tank in gallons? Hopefully that SCADA alarm isn't one of my tanks overflowing. Now that I've cleared that alarm, we're going to pull our known and our unknowns out of our word problem. So what you know is that you have a radius of 16 feet, a height of 23.5 feet, and we don't know the capacity in gallons. Again, we're switching back to 3.14 times the radius squared times height, because again, this is given the radius. Everything's already in feet, so we can plug it into our formula. So 3.14 times 16 foot squared, so times itself, times 23.5 feet. You're going to do your multiplication. You get 18,890 cubic feet. So we're going to convert this to gallons because we're looking for the capacity in gallons. Again, 7.48 gallons per cubic foot. Hopefully, if I say that enough, one day I'll remember it and not need the formula sheet, but we'll see. That's going to be times the 18,890 cubic feet. Again, cubic feet will cancel out, leaving you with gallons. And the answer is 141,297 gallons. How many gallons of water are in a tank 72 inches in diameter by 30 feet high when the water is 16 feet deep? So first, let's pull out our known and our unknowns from the question. So what we know is that the diameter is 72 inches, the height is 30 feet, and the depth of the water is 16 feet. What we don't know is how many gallons of water are in the tank. This time they gave us the diameter, so it's 0.785 times the diameter squared times the height. Remember, volume solves for cubic feet, so we need to convert the inches into feet. There are 12 inches in 1 foot, and we want the inches to cancel out, so it's going to go in the bottom. So 72 inches times 1 foot over 12 inches. It's going to end up being division, and your inches will cancel out. And that's going to give you a diameter of 6 feet. One thing else to notice in this question is they've given us more than we actually need. So the tank is 30 feet high, but we're solving for how many gallons that are in the tank, and it's 16 feet deep. So you're not going to need the 30 feet because it's not filled to the top. So we're going to do 0.785 times the diameter that's now in feet, so 6 feet squared, times, again, the depth, because it wants to know how many gallons are in the tank, not how much the tank will hold. So 0.785 times 6 foot squared times 16 feet. And that gives us an answer of 452.16 cubic feet, again, because it was feet times feet times feet. And it wants how many gallons of water. So there are 7.48 gallons per cubic foot times 452.16 cubic feet. The cubic foots and cubic feet will cancel each other out. You're going to be left with gallons. 3,382.15 gallons. What is the volume in gallons of a day tank that is filled to 3 feet and is 20 inches wide? Still pulling out our known and unknowns from word problems, because that's what we do around here. What you know is the depth of 3 feet, and the tank is 20 inches wide. If you remember from the diagram and what we talked about there, width is equal to the diameter, because the diameter is the distance across the circle passing through the center. So we're going to be using the diameter formula. And that is 0.785 times the diameter squared times height. Again, volume solves for cubic feet in our field, so we need to convert the 20 inches into feet. There are 12 inches in a foot. The inch is going to go on bottom, so it cancels out. So 20 inches times 1 foot over 12 inches. Inches cancel out, and you're left with 1.67 feet. So now that it's in feet and the depth is in feet, we can plug that into our formula and solve. We have 0.785 times 1.67 feet squared times 3 feet. You do the multiplication, and your answer is 6.6 cubic feet. Somebody's knocking on my front door, so we're going to need to convert to gallons. 6.6 cubic feet times 7.48 gallons. Still over a cubic foot. Still canceling out to leave us with gallons. And when you do that multiplication, you're left with 49.4 gallons. So there you have 5 questions on the varying ways you can be asked to solve for volume in gallons of a cylindrical tank. To be fair, we also solve for cubic feet, so hopefully you picked up on how to do that too. These more simple formulas will be the building blocks for more complicated problems later. Hopefully this video helps you learn. Thanks.